In this video, I'm going to be reviewing week 1 of differential equations. So for problem 1, for the following equations, provide the dependent and independent variables. For part A, the dependent variable would be f of x, since f of x changes based on whatever is put into x. For part B, the dependent variable would be y, and the independent variable would be x. This could be easily seen if it is rewritten like this. When it's rewritten like this, we can easily see that dy will always change based on whatever is plugged into x, since we are differentiating in respect to x. In part C, the independent variable is s, since whatever we plug into s changes dh, since we are taking the equation in respects to d of s. For number 2, circle all the following expressions which are differential equations. So going over number 1, this is not a differential equation because it is not even an equation. To have it be an equation, it needs to have an equal sign, like this. Since there is no equal sign, it is not an equation. For part 2, it is a differential equation, since there are 2 derivatives in this equation. For part 3, it is also a differential equation, since there are 3 derivatives in this equation. Part 4 is also a differential equation for the same reason. Part 5 is not a differential equation because it does not an equation. Part 6 is a differential equation since the derivative is here. Even though it is inside of a sine function, it is still a differential equation. Part 7 is not a differential equation. There is no differential equation inside of it. For this to be a differential equation, one way would to be to set y like this. These parentheses make the equation a differential equation. Part 8 is a differential equation, since there are 2 differential equations in here. Part 9 is not a differential equation, since there are no differential equations in the equation. Part 10 is a differential equation, as there is this differential equation right here. For number 3, consider the function y equals x squared. Compute y prime and y double prime. So to derive this, it's pretty simple. Y prime is equal to 2x, because what we do is we bring down the power and then we subtract it by 1. To get the second derivative, we have y squared is equal to 2. Since there's basically a 1 right here, we would bring that down. 2 times 1 is 2, and then we subtract 1, and that means we're left with 0 on the top. For part B, does y satisfy the equation? Justify your answer. Yes, it does. And here is why. We're going to use part A and plug in these values. So x squared. It's a horrible x squared. X squared, that's not much better, times 2 minus x, and then y prime is 2x. So this turns out to be 2x squared minus 2x squared, which equals 0. Therefore, it is justified.